Hello, my name is Soni Midhat, and I am a virtual content specialist for Algebra 2. And so today I am going to be talking about the launch activity for Unit 6, Day 12. This is a big day. How do we graph sine and cosine functions? So I'm going to talk about the launch portion and a little bit of the explore portion as well. So this is what the launch activity looks like. And so essentially the purpose of this launch, this warm up, is to really get students ready to, unwrap the unit circle in the next activity and to start seeing what the graphs of cosine and sine look like for the very first time in this unit. So part of the thinking of cosine and sine as functions is really understanding their input and their output. And so the prompts in this activity, they ask students to informally describe the output of, the two trig functions by focusing on each coordinate of a point on the unit circle. So what you'll notice here is that you do have a unit circle and there's a point at 1, 0, point P. So students are asked to describe how the coordinate of P, how the x coordinate of P first, how that changes as it rotates once counterclockwise around the circle. And then also how the y coordinate of P changes as it rotates once counterclockwise around the circle. So again, you want to definitely invite students to really share their responses. And so some responses that you might receive, the x coordinate, well, it starts at 1. It starts at 1 right here, and then it decreases to 0. It then goes to -1, and then it finally reaches back at 1. Whereas the y coordinate, right? The y coordinate starts at 0, it increases to 1, eventually decreasing to -1, and then increases back to 0. So those are some sort of responses that you might get from students. You definitely want to invite them to share their descriptions and highlight, anyone who says any responses that use actual values, such as the 1, 0, -1. Now, this is sort of hard to visualize just when looking at a slide, right? So I think a really great support towards this launch is to look at the unit circle on Desmos and really sort of have a slider to animate this. So I'm just going to show you what this might look like. Now you'll notice here, I have a unit circle that I've graphed, x squared plus y squared equals 1. And then I've hidden this point right here, but I put in a point cosine A, comma sine A. And I made sure to label it. That's how I can see the coordinates. Now the reason why I wrote cosine A, sine A is because it opens up a slider. And so here, this slider, I put it from 0 to 720. And so now what's going to happen is that while students are either thinking this through or while you're having your discussion, you can really move this slider and demonstrate how that point, how those coordinates are changing on that point, right? So again, if I look at this at that first point, right, where it was 1, 0, I notice the x coordinate starts at 1. And then it moves over, right? It decreases to 0. It decreases some more until it hits -1. And then it increases back to 0. And so and you'll also notice that I did it to 720 so that there's actually 2 rotations of the circle. So students can see, this sort of cyclical motion that's going on. So this is the warm-up portion of this lesson. And again, it really is getting them ready for the explore portion of this day. So I'm going to talk about just the first part of the explore activity. And so what you'll notice is that it's asking you to use an applet. It's called Do the Wave. And you're going to use this applet to really complete these two portions, portion C and then portion D, but I'll focus on portion C. It's going to ask you to use that applet to really, plot the points for y equals cosine theta, and then eventually where y equals sine theta. So the applet looks a little bit like this, and it's actually a great applet because what happens, again, here's a slider as well, but as you move the slider, it's giving you different angle measurements in radians. And so it starts at 0, and then it goes all the way up to 24 pi over 12, which in this case, of course, is 2 pi. So you want students to do these step by step, right? So I'll just focus on the using technology to plot the values of y equals cosine theta. And so my recommendation is to definitely have students use Desmos when it says use technology, use Desmos to do this. And so what I would say is have your students really kind of split their screen up. So half of the page will be on this applet, and then the other half of their page will, half of their screen rather, half of their screen will be on this applet, and then half of their screen will be on Desmos. So pretty much just sort of having two pages on their screen side by side. And so what they can do is for each angle, they can pretty much, see what's going on here. And this is actually really important. They don't want to move this. You want to remind them not to move this part right here. Only move the slider, because that'll give you the true coordinates on the unit circle. So let's say they wanted to plot the coordinates at 3 pi over 12. So what they could do now is they can go to Desmos, and they notice that this coordinate is going to be 3 pi over 12, comma, 0.7. So they would just go over to Desmos and they would plot that. They would write 3 pi over 12, comma, 0.7. And so you'll know, 0.7, right? And so you'll notice, didn't come. Okay, there we go. You'll notice that that point happens. And so you want students to plot these points, and eventually what's going to happen is that they're going to start to see the sine and the cosine graphs, right? If it's the y coordinate versus the x coordinate, they'll start to see it. The y coordinate, they'll see the sine graph. The x coordinate, they'll see the cosine graph. So again, really using this applet together with Desmos will allow students to see it. And I've actually done this here too, so you can sort of see the final product, hopefully what your students will also see. It does take some time, and also just consider the fact that that applet, it's in multiples of pi over 12. So you may need to point out that, 5 pi over 6 and 10 pi over 12 are the same coordinates. So just keep that in mind.